All right, we're about to start unit 4, what is this, 4.1. This unit has a ton of vocabulary. Now, I'm not necessarily going to quiz you on this vocabulary, but you need to know what it means. So we're going to be combining, we're doing, this is adding, subtracting, multiplying, and dividing polynomials. Well, if we don't know what a polynomial is, we can't add, subtract, multiply, or divide it. So we're going to learn a bunch of vocabulary here. You have to know this vocabulary, not because I'm going to quiz you, but because if you don't know this vocabulary, you can't answer questions about things because it's going to use this vocabulary. You kind of see what I'm saying? You got to know it to be able to answer it. We are going to cram a ton of stuff onto this page. So, okay, so yeah, sorry, but not sorry. Okay, so first of all, there are two ways that we classify polynomials. First of all, a polynomial is an equation or expression containing one or more terms. So what that means is poly means many, like Polynesia, or I don't know other poly words that I'm going to say on a video, but Polynesia is many islands, polynomial is many terms. So it's an expression with many terms, one or more terms, okay? And it might be an equation, it might be an expression. So it might be like x equals 5, it might be x plus 5 equals 7, it might just be x plus 5, okay? And I just went ahead and put coefficient here, and then I'm not sure what I was going to do with this, but we're not doing it now, so now we've got this big thing taking up space. Anyway, all that to say. So polynomials means one or more terms. So it's a expression with one or more terms. So when we classify polynomials, they have two names. They have a first name and a last name. So our first name is by degree, and the degree it means what is the highest exponent that you see. We call it the highest order exponent. So if I give you an expression, there's a bunch of different ways we can name them. So the first one is 0. So we're going to learn why the degree of a constant is 0. We're going to learn that later in unit 6. Okay, so but for now, we call something with the highest order exponent of 0 a constant. And when you think about 0, just think about this. There is no variable. Okay, so it's just a number by itself. Now, it may be more than one number because, again, these are polynomials. But the first name of this polynomial is going to be by degree. So maybe we just have like a -7, just hanging out, chilling, just a -7. Or maybe we have 23 plus 7 minus 12. Okay? Those are all variables those are all terms with no variable. That makes this is a constant polynomial, and so is this. So that means their first name is constant. Okay? Now, the second type of first name we could have is if the highest exponent that you see is 1. So when do we see a 1 exponent? Well, let me give you some examples, and then we'll kind of pull that apart. So we have like 3x minus 2. That's maybe one of them. We might see 2x. We might see 27 minus 16x. Okay? What these have in common, and what I'm hoping that you're kind of ping in the back of your brain, hang on, I'm going to grab another pen so I can show you, is these all have the invisible exponent. So remember, we have the invisible 1 exponent. These all have the invisible exponent. So how many x's are there? There's 1 x there. Okay? So the 1, we're going to say that is our invisible exponent. Okay? So these have no variables at all. This has the invisible 1. And again, when we get to unit 6, we'll kind of start talking a little bit more about the 1 and the 0 exponent. Okay, but these are linear, and they should look familiar to you because these should look like linear functions. Okay, or linear well, these would be linear expressions, but like if they had an equal sign, they'd be linear equations. Okay, so the next thing that we could have is we could have a highest exponent of 2, and that will be quadratic. So we might see something, whoops, wrong color. We might see something like this: 12x minus 2x squared. That might be an expression we see. We might see 5x squared plus 2x plus 1. Okay? And what makes these quadratic is that the highest variable we see in them is 2. That's the highest variable we see, and that makes these quadratic. Okay? The next one, the highest variable we see is 3, which is cubic, and that will be a third degree, but it's special, so it has its own name. So that might look like this: 7x squared minus 5x minus x to the third. And we see that highest exponent, especially when we put in our invisible, we have a 3, a 2, and a 1. 3 is the highest, cubic wins. So this is cubic. Now, if we go any bigger than 3, we don't have special names for them. So that's just going to be an nth degree, okay? And it's called actually an nth degree polynomial. So we call it an nth degree polynomial. And that's anything bigger than 3. Anything bigger than 3, we call it an nth degree polynomial. All right? I'm sorry, it was a little blurry. Okay, so if it's bigger than 3, we call it a something degree polynomial. So, for example, so it's a blank degree polynomial. And that the numbers that you see there, you might see like fourth. You're not going to see third, or fifth, or sixth, or so on. Okay, so fourth, fifth, sixth. I guess we can erase that. Okay, so that's the things you're going to see there. So, for example, if you saw this, x to the fourth plus 2x to the third minus 4x, okay, we have our invisible here. The highest number we see is 4, so we would call this a fourth degree polynomial. Okay? So that's our first name. Our first name has to do with degree. And again, degree is the highest exponent. Not just an exponent, the highest exponent that you see. All right? Now, that's the first name. Now let's look at the last name. The last name has to do with how many terms are in that expression, okay? So we have monomial, binomial, trinomial, and polynomial, okay? So a monomial is something that has one term. So some examples of that might be like 2x, or 5, or 8x to the 12th, okay? All that you see there is one term. So this is a monomial. Mono means one, okay? Binomial means we've got two terms, okay? So we might see something like 27 minus 16x. We might see 12x plus 3x squared. We might see 16x squared minus 1, okay? These are binomials because they have two terms in each of them, all right? The next one we're going to see is a trinomial. I know you're like, oh my God, we just keep going. This one is 8x squared, like plus 3x minus 6x to the 7th. It's got 1, 2, 3 terms. That makes it a trinomial. All right? And if we get any bigger than that, we have a polynomial with blank terms. So like if you have more than 3. We're going to have a polynomial with blank terms. So like, for example, this one, x to the fourth, sorry. I'm going to erase that because y'all are going to be like, what does that say? X to the fourth plus 2x to the third minus 4x plus 1. Okay? This is a polynomial with 1, 2, 3, 4 terms. Okay? So that's how we give them their first and last names. Now, so what happens when we're kind of trying to put all that stuff together? All right, so let's do some examples. And we're going to be doing them all over the place, okay? So let's do one up here. So the first one, let's say we have 12x minus 3x squared. Okay, so the first thing I'm going to do is I'm going to find its first name. I'm going to look at its exponents. Well, I have a 2 and a 1. Well, 2 is the highest exponent. That makes it quadratic. So this is a quadratic Okay, so that's its first name, quadratic. Now we look at, for the number of terms for its last name. Well, it's got 1, 2 terms, so that makes it a binomial. So this guy is a quadratic binomial. All right, let's try another one. We have 2x to the third. Okay, so we're going to start by looking at its highest exponent, which is 3, which makes it cubic. Okay, now we look at the number of terms. There's 1, so it is a monomial, a cubic monomial. So again, first name, last name. First name is based on his exponent. Last name is based on how many terms there are. Okay, let's try this one. This one's a lot. Okay, so let's just give it a go. X to the 5th plus 2x to the 3rd. We should zoom in a little bit. Minus 4x plus 1. Yeah. Okay. So I start by looking for his first name. Well, I've got an invisible 1 there, and I got nothing here, so that's my highest one. Well, that doesn't have a special name, so it's a blank, it's a 5th degree polynomial. Holy smokes. Okay, so this is a 5th degree polynomial, all right? And it's got 1, 2, 3, 4 terms. That doesn't have a special name, so it's a polynomial with 4 terms. Now notice, it was already a 5th degree polynomial. And its last name would be polynomial with blank terms. But I'm not going to say 5th degree polynomial with 4 terms. That's just crazy, right? Like, that's just extra. Why would I write that twice? And it doesn't even sound right. So it's a 5th degree polynomial with 4 terms. Okay? Now, I want to take a look at one that we did before, because kind of jumping off of this, I want to just kind of look at something a little different. So let's look at this one that we had for trinomial, right? It was 8x squared plus 3x minus 6x to the 7th. Let's just real quick, we'll rewrite that. 8x squared plus 3x minus 6x to the 7th. Okay? So, when I look at this one, what did I say about this one? Okay. This is a, okay, so it's, if I look at the exponent, it's a 7th degree polynomial. Okay? And there's 1, 2, 3 terms, which makes it a trinomial. But that sounds kind of silly, because it's almost like it's got 2 last names. That's like Maggie Deal Deal. No. It's a 7th degree polynomial, trinomial. Will that be like calling something like a quadrilateral rectangle? It's a type of rectangle. It's already got a special name, so we don't give it the unspecial name. It's a 7th degree trinomial. If it's got a special name, we don't say it's a polynomial. Okay? Now, the very last thing I want to talk about, and then I swear I'm done, is if we look at this one right here, we have something called, so we've looked at standard form. So you see, like, we have standard form right here, and we've looked at standard form on our formula charts. Let me grab a, of course I can't find one now, that would be just too convenient. Also, like right here, we have standard form here, which is a whole different story. But this is kind of more what standard form looks like. When you start getting into like everything from quadratic and beyond, standard form has you listing the highest exponent. So we have a quadratic term here, then the linear term, then the constant term. And you notice it's quadratic, linear, constant. So we always go from the highest exponent down, okay? So standard form of any polynomial, okay, standard form of any polynomial, whoopsie, sorry, that just all happened, goes from the highest order exponent, which basically means the exponent with the highest number, and then it decreases. Okay, so for example, if we looked at, wait, where did it go? Oh my gosh, there's too many things. Okay, so it was 8x squared plus 3x minus 6x plus 3x minus 6x to the 7th. Okay, so if I look at this, I'm going to look at the exponents. So I have a 7, a 1, and a 2. I start with the highest one. So when I turn this into standard form, I'm going to start with negative 6x to the 7th. Why negative? Because the negative is part of that term. That's the highest number. It goes first. The next highest number is positive 8x squared. And the next one is positive 3x, and I'm out, so this is now written in standard form. Okay, this is a lot of vocabulary. We're going to have a study mate or a Quizlet for you guys to use, but yeah, that's all.